let's work these out. Number 13. Number 13, it is that simple because you have e and ln, e raised to the ln, which means things are going to cancel out. So I'm just going to get the 5x. So I don't even have to do anything more to the side. I just get 5x is equal to x plus 8. And then solve it. So subtract that. So I get 4x equals 8. X is equal to 2. The only thing I would double check on that is make sure if you plug your answer back in, make sure you don't get like a natural log or a log of a negative number. So if I plug 2 back in for x, I'm going to get natural log of 10. That's totally fine. So that answer works. So that's 13. Is that okay? May I go to number 14?
You may.
All right. Number 14, I'm not going to mess with the left side right now. 2/3 raised to the 2x power. It's already in its basic prime components. But let's focus on 27 over 8 for a minute. Let's realize I can rewrite this to be like this. You agree with that? And then I could break 8 over 27 down to 2 over 3 to the 3rd power, but we have negative, so it's that. So now I'm going to put this in place of this, but I still have this portion here I have to worry about. What is that negative 3 exponent going to do with the x minus 5? It's going to distribute over it. So I'm going to get 2/3 raised to the 2x equals, I'm going to replace this right here with 2/3 to the negative 3, which also had that still. So it's going to look like that. Exact same bases. What can I do with the exponents now? Set them equal to each other. So I get 2x is equal to, I can distribute over that. So I'm going to get negative 3x plus 15. And then let's solve it. So I'm going to bring the minus 3x over. It's going to be 5x equals 15. So I'm going to get x is equal to 3. I don't have any log or natural log in there, so I don't have to worry about an answer not working. That should work out just fine. Okay. May I go to number 15? Number 15. I have this log base 2 I got to worry about. What? Yeah, dude, I thought you said, do I need some help? I'm like, uh-oh. Did I say something? Did I slur? All right, so snail, absolutely. So 2 to the 4th power is equal to x plus 2. 2 to the 4th is pretty easy to figure out. 2, 4, 8, 16. So you get 16 is equal to x plus 2. Subtract 2, so I'm going to get x is equal to 14. I was dealing with the log in the beginning, so let's make sure if I plug 14 back in, I don't get a negative or log of a negative. So 14 plus 2 is 16. Log base 2 of 16, totally fine.
Could you have just raised both sides to the 2?
Oh, you mean do this? Like that and that? Yeah. Absolutely. And that all of a sudden becomes the same thing as this. Oh, that should be a 2. I can do this well. So that's going to be the same thing as that. It's your choice which way we want to go about it. So good eye on that one. Can I go to number 16? So number 16, what am I going to do to get rid of ln? I can't snail it because it's not log base of a number. Yeah, each side is going to become its own exponent. So I'm going to go e raised to this side and e raised to this side. This cancels out, leaving me x minus 5 equals e to the 2nd. So then I'm going to add 5. So 5 e to the 2nd. This would be one you'd probably plug into your calculator and be able to get an answer out. If this was on the non-calculator portion, this would mean that answer is totally fine because I'm not expecting to know what e squared is. We good? 17. So log base 6, 2x minus 5 plus 1. Log base 6 of 7x plus 10. I can't just go 6 raised to the 6 raised to the 6 raised to the, that property won't work. Anybody have an idea how we can go through this problem? a little bit of a puzzle. I can't do that yet. That property won't work yet. It's going to have something to do with condensing, but if I condense, I have to move something over to one side and something over to the other side.
You can make 1 log 66.
So I'm going to move this over there by subtracting it. I'm going to move this over here by subtracting it. So I'm going to get this. Is that okay so far? Don't fall asleep. How can I condense the left side now? Yeah, make it a fraction. Good job. So log base 6, 2x minus 5 over 7x plus 10 equals -1. Now what can I do? I can snail it, make both sides. So it's your choice how you want to do it. So 6 raised to the and 6 raised to the. I'm going to get 2x minus 5 over 7x plus 10 equals 6 to the -1 power. What's 6 to the -1? 1/6. Good. Cross multiply, or if you're the mathematician, products of the means is equal to the products of the extremes. I like cross multiplication. So we get that, and then I'm pretty sure you could solve that algebraically. Is that okay? Does anyone need me to solve Algebra 1 problem? Alex? You need it on a number line. Yes, he has.
He's been here every day.
No, he has not. This is his first time.
I've been here all week.
Walker's been here too.
No,
Well, this is
No,
no,
Walker was-
review guide.
no, he wasn't.
Yeah, he just had his review guide.
All right, number 18. Is this okay not to work this out? Does anyone need it worked out? I mean, just distribute the 2 or the 6, distribute the 1, get x alone. The only thing you'd have to watch out for on your answers is what? If I solve this, what do I have to watch out for? There's log on both sides. Can you have a log of a negative? Make sure whatever your answer is, if you plug it in here or you plug it in here, you don't get log of a negative. Okay, that's the only thing to worry about. 18. I think I can get both sides in base 5. How could I rewrite this not having a radical? Not 1/5. It's a square root, so the square root's the 1/2 power. So if the square root's the 1/2 power, that means that's going to be x to the, or 5 to the x over 2. Is that okay? How can I make 25 base 5? How can I make 25 base 5? 5 squared. Make sure you distribute it with this. Like bases, exponents equal to each other. Alright, so I'm going to move this 2 over, multiply it by 2 and 2. That's gone, so I get x equals 4, 3x plus 5, and then solve it. Does anyone need me to work out an Algebra 1 problem? Can I have a negative exponent for an answer? Can I have a negative exponent for an answer? If you do, it means you're just flipping over the fraction. So a negative exponent is totally fine to have. Excuse me. So I'm not going to work out the rest because I'm pretty sure you can do that. Yeah. Oh, so what I did is I had x over 2. So what I'm going to do is, so I don't have a fraction on the side, I'm going to multiply this side by 2 and this side by another 2. So that 2 and 2 gives you the 4. Is that all right? Number 19. Can I move to 19? Talk to me. What should we do? Make everything so base 2. Good. So how would I make 8 base 2? Cube. So 2 cubed is 8. So 2 cubed is 8. But remember, I have this. So I'm going to just do one of those. Is that all right? The next portion's already in base 2, so we're fine. How do I make 32 in base 2? 2 to the 5th, because 2, 4, 8, 16, 32. So 2 to the 5th power, same as 32. That has to be with this exponent. Okay? Like bases being multiplied together, what happens to the exponents? Like bases being multiplied together, what happens to the exponents? Do what? Not multiplied. Yeah, like bases when being multiplied, you add the exponents. So we're going to get 3x minus 7 plus x. Does that make sense? Is equal to 5 times 2x plus 9. Go ahead and solve that problem. A negative answer is fine to get because we're not dealing with log or natural log. Is that okay? Can I go to number 20? Problem number 20. I think I would divide each side by 4 first, just so that's gone. So that's going to give me 10 to the 2x plus 3 equals 4 goes into 2056. Well, 4 goes into 25 times, goes into 5 once, goes into 16 4 times. So I get to that. Did I do it right? 4 goes into 25 times. 4 goes into 5 once. 1 left over. 4 goes into 16 4 times. I do what I can for you. Or on your calculator, go 24 divided by 56, or 2056 divided by 4, and you get 514. All right. What do you think? Where should we go from here? Log it? I like it. So, now, I usually choose natural log, correct? But I'm going to choose log on this one. What reason is sticking out that I'm going to choose log versus natural log? It's base 10. Good. So if I go log by itself is base 10. So that's going to eliminate that. That's going to give me 2x plus 3 equals log 514. This would probably be a calculator problem to work on. So anyone have a calculator out real quick? If so, can you tell me what log 514 is to 2 decimals? Say it one more time. Thank you. 2.71, 2x plus 3. Hey, Bob. And then we're going to solve that. So subtract 3 divided by 2. My original answer did not have log or natural log in it, so we can probably assume that the answer we get by working that out will be. Yeah, if this was on a non-calculator, I would have the answer be log 514. I'd have the 514 in parentheses minus 3 all over 2. If that was on a non-calculator part. If this was on a non-calculator part, I would imagine that the number it's equal to could be set into an easier base, but I don't think 514 is going to break down nicely. Problem 21. Problem 21. Where should we go? Subtract 8. Love it. Okay, get 5x, 3x minus 1. Bless you. Equals 11. So you guys went log base 5. I got to think about that. I like it. I like your thinking. Log base 5 on both sides. You know what? I'm going to stick with it. I like it. All right, the reason I chose to do log base 5 on both sides is that's there. Okay? So this cancels out. That leaves me 3x minus 1 equals log base 5 of 11. I like that. That's good thinking on your part.
No, we already did 8.
We already subtracted that 8, right? Okay. Now, here's the tough part. If this was on the calculator portion of the test, take this and tell me what log 11, make sure you have that in parentheses, divided by log 5 in parentheses would be equal to. Give me 2 decimals. Log 11, make sure the parentheses are closed, divided by log 5. How much? 1.49? Good. All right, and then once you get to that point, add 1, divide by 3. There's your answer. Okay? Why don't you guys take a couple minutes to work out 22, 23, 24, and 25. Work out 22 through 25, please. I'll give you about 3. All right, first problem. This, I imagine, would be on a non-graphing calculator portion of the test. They want you to graph it. So, let's go to the T-table. What's up, bub? See Robeson out there?
No.
Now your turn to watch.
here.
Sweet. All right, help me out. What are some things that can work? What if I had log base whatever of 1? If I had log base whatever of 1, what would that equal? 0. Okay? So what would I have to plug in here in order to make that a 1? Not -2. What do I want inside? I don't want it to be 0. I don't want it to be negative. I want that to be a 1. So if I take -1, plug it in, -1 plus 2 is 1, right? And log base 5 of 1 is equal to what? 0. And 0 minus 4 is equal to what? Is that okay so far? So I get -1, -4. Okay? So what do we want our numbers in the parentheses to be base of? 5. Good. What would I plug in to make a 5 in there? 3. So if I plug 3 in, 3 plus 2 is 5. Log base 5 of 5 is 1. So realize that this is raised to an exponent of 1 right now. So log base 5 of 5 raised to the first is 1. 1 minus 4 is? -3. So 3, -3. Okay? And then I think we could do one more. I don't know if we can graph it or not. So I was able to get a 5 in there. What's the next number that would be base 5? 25. So what would I have to plug in there to get to a 25? 23. So if I plug 23 in there, 23 plus 2 is 25. 25 is the same thing as 5 squared. So what's log base 5 of squared? Log base 5 of 5 squared is 2. 2 minus 4 is? So then 23 way out here, -2. So this graph is basically doing this. Okay? What is my asymptote of this problem? What can I not allow this to be equal to? Negative as well as 0. So what's the smallest value I can plug in? Can I plug in -2? No, -2 is not going to work. In fact, -2 is going to be, that's going to be our vertical asymptote to this problem. Okay? So my domain of this problem is going to go from what to where? My domain of this problem is going to go from what to where? There you go. -2 to infinity. What is my range? Range is going to go forever downward, so it's going to go to -infinity. It's going to grow. It's going to continue to grow. It's not going to grow as rapidly, but it eventually one day will get to infinity. So that's my domain and range of number 22. And that's what the graph would look like. Okay, so again, I wanted to get, yo! Remind me to unmark you guys.
Wake up.
Yeah.
If you like plug that into the graph calculator, it doesn't go all the way down to negative. It like just starts at a point and goes to
Yeah. And the reason is there's something on that calculator called a tolerance. So it's what it did is it's going to get to negative infinity real quick, or it's going to get to its maximum negative value real quick. So that's why it's going to look like it starts and goes. But it is indeed going to forever go right along this vertical line. So that's what you have to be aware of. The reason I say that is I can plug in negative values really close to -2. If I were to take, like negative 1.9999999, that would give me log base 5 of 0.000000001, which is way down at negative infinity. It's way down in the negative direction. But the calculator, it's just because the calculator is not perfect. There's tricks you can do to the calculator that'll make the tolerance better, but it becomes a real pain on every problem because you have to adjust the tolerance on every problem. So it's not worth doing. Is that okay? All right. Can I move on? Number 23. So I have negative log x minus 5 minus 2. All right. What should I plug in there? Because I can have log of 1, and log of 1 is equal to 0. What should I plug in there to get log of 1?
-4.
6. 6 minus 5 is 1. Log of 1 is 0. Negative of 0 is still 0. Added to -2. So I get 6 -2. All right. So what base is this log in right now? It's in 10. So I want to get to factors of 10. So what would I have to plug in there to get to the first factor of 10? 15? So if I plug 15 in, I get 15 minus 5 is 10. Log of 10 is 1. The negative of 1 is -1. -1 minus 2 is -3. So way out here on 15, I'm at -3. So way out here at 15, I'm at -3. So this is kind of doing one of these little Jim Dandies here. You like Jim Dandies? So this is doing this. Five, 6. So that's basically what that graph is going to look like. You don't like the Jim Dandy? On some of you can. 4 functions, totally fine. But not graphing on both parts. There's 2 parts to it. It could be on either. But I don't know if I'd give you something quite that tough on the non-calculator.
For this one, how do you find the absolute values?
I was just thinking about that. So yeah. Oh. 6, 5. Did that right? 6 -2. 15. It goes down?
Yeah, I just grabbed
Like this?
Yeah, so it starts at the x6 -2. Yes. And goes down.
Like that?
Like to the side.
Like that?
No, it's going down to like
Like that?
no, down to like try to
Like that?
yeah.
Like that? That would make sense. Okay. So my asymptote here is going to be 5 because I can't have a log of 0. So x equals 5 is my asymptote. So my domain is going to go from 5 to infinity, while my range is going to go from negative to positive infinity. Sorry about goofing up that graph. So this is what it looks like that one. All right. 24. Almost done. More. All right, problem number 24. Problem 24. So I get 1/4 x minus 4. What would happen? What would happen to this fraction if I were to plug numbers that continued? What if my exponent became negative? What would happen to the 1/4? It becomes a whole number. It flips over. Perfect. Okay, so first one I'm going to plug in is I'm going to plug, let's see, if I plug 4 and I get 4 minus 4, so I get 1/4 to the 0 power, which is what? 1/4 to the 0 power is what? 1. 2 times 1 is 2, plus 1 is 3, so I get 4 comma 3. So it works right there. If I plug, I want to make it negative. So what if I were to plug 3 in? I get 3 minus 4, that's negative 1. So 1/4 to the negative 1 becomes 4 to the first. 4 to the first is 4. 4 times 2 is 8. Plus 1 is 9. So I get 3 comma 9. So this graph is doing like this. Is that growth or decay? Decay. Can I plug any numbers in? Do I have log or natural log? I don't. So my domain is going to go from negative to positive infinity. My range is also going to go from negative to positive infinity. Hang on, I take that back. My range is going to go from 1 to infinity. My asymptote is right here. I have y equals 1 as my asymptote. I won't go below that. All right, last one. Can I make it? Pretty easy one to do. I get 2 to the x. Negatives are going to work. If I plug 0 in, that's going to give me negative 7. If I plug 1 in, that's negative 6 minus 10. So 1, negative 10. So this graph we got our asymptote here, so this is what this graph's doing. So my domain will be negative to positive infinity. My range will go from negative 4 to negative infinity. So this is what my plan is between now. Obviously, we have 2 weeks off. If you choose to take all 2 weeks off, good for you. But please realize we have a test coming back to Tuesday and Wednesday after break. So Monday, we can finish this review. And any other questions? And then Tuesday, you have the part 1 of the test. Wednesday, you have part 2 of the test. And then after that, we're just reviewing the rest. If you would like part of the final review, if you want to start on the final review packet, come see me and I'll get you it. If not, I'll get